Assalamu alaikum students. This time I again welcome you to vector calculus lecture number 10. I have mentioned here that it is actually we are teaching at this time the 5-year integrated course in mathematics, doing honors in mathematics. We are making the lectures for those students and BSc students who have this vector calculus in their course, especially the students who are pursuing the courses in BTech engineering in different streams do have this their application of line integrals. In lecture number 10 I discussed with you the line integral, definition of line integral, how we evaluate line integral, what is a line integral actually we did in lecture number 9 in fact. Now in lecture number 10 we will be having the very important this application where we use this line integral. What is the physical interpretations of this line integral? It is interpretations we are using in different fields. Number in physics we use it the work done by a force in moving a particle from along a curve from one place to another place. What is the work done by that force? We find that by using the line integral. In certain cases we also use the line integral in fluid dynamics, in fluid mechanics dynamics, where we find that the circulation in fluids. In any way, let me have this application part of this line integral. Before I take the applications of this line integral, I would like to introduce the working rule. I will discuss with you the working rule, how we apply these line integral. This is working rule for evaluating line integrals. This is the working rule. You see, let us start this. Let us consider the vector point function. We consider the vector point function. Say it is given by f of, in space we take it, it is f1i plus f2j plus f3k. These are the components of this, with r you take it position vector, or you may take r as xi plus yj plus zk. This implies that your dr, or you may denote this by this, dr is I dx plus j dy plus k dz. This is how we evaluate the value of this r. The position vector of the point will be given by this xi plus yj plus zk. We find here in this way. Well, after this you have now line integral. Now line integral over the given curve C, this I named point number 1, over the given curve C is given by f dot dr, which is same as integral C f dot dr. You may write this will be now integral over the curve C. What is your f? It is f1i plus f2j plus f3k. It is dot with I dx plus j dy plus k dz. You are replacing by this. You see, when you find out this, so line integral of C f dot dr is given by now over the curve C. It is f1 I dot I is 1, f1 dx plus f2 dy, j dot j is 1 plus f3 dz. That means actually in the line integral we integrate the components of I with respect to dx, components of j, that is f2, with respect to y, components of k with respect to z, dz in space. When the function is in, the curve is in a space, when it is in space. This is the first point that you must remember while applying this, the application of line integrals. This is the working rule. One more thing I want to share with you. Let me rub it here. Second point is it is if the equation of given curve C is given by, say it is x is equal to some function of t, y is some function of t, we write in this way, z is some function of t, that is these are the functions of t. And if at a and b, what is this a and b? You have seen this in lecture number 9. These are the endpoints of the curve. T is equal to, at a, t is equal to t1, at b, t is equal to t2. Then we evaluate the line integral for this curve in this way. Then integral of c f dot dr, or small r you may write, it is given by this integral t1 to t2, because you are getting the endpoints of this lower limit and upper limit, I mean. This is your, in this case, f1 dx by dt plus f2 dy by dt plus f3, f1 f2 f3 you know from previous point, dz by dt into dt. In this way we go. When we are, the equations of the curve are given in this way, this gives us the lower limit and upper limit, and the parameter t gets involved, the function of t. There is a parameter t that involves in from x, y and z. So we evaluate this line integral in this way. This is second point that you must remember. You will come across when you have the equation of the curve given. I will share with you some questions where you can see how we proceed. In any way, well, I want to share point third with you. We have seen that curve A to B is given by C. What is this? Refer lecture number 9, where I just represented the curve C from A to B. It was an open curve. The curve C can be, you must note, this curve C can be a closed curve. It can be closed curve, open. It can be even straight line, even triangle, square, ellipse, circle, etc. Curve can be this. Now in case of closed curve, like this circle, this, it can be closed like this, closed curve. The the line integral is denoted by like this, closed curve over C. We use this symbol. We require this symbol also when we discuss the Green's theorem in planes. There we have to deal with the closed curve. There we write the circle like this. There is a line integral over the closed curve C. Thus, for the closed curve, the line integral is denoted by integral of closed curve over C f dr dot है f dot dr, or you may write C f dot dr. This is also line integral, but it indicates that we are evaluating the line integral along what? Along closed curve. Okay, these are some points, that these are the working rules that I have shared with you. Now I will take the first physical interpretation of this line integral, that will be the work done by the force. This is physical interpretations of line integral. It is a subtopic that I am dealing. Physical interpretations of what? Line integral. Actually, it is the application part that we are doing here, that I am discussing with you. The first, this interpretation, it is the first one, first application. First application of this line integral is, it is used for work done by a force. Work done by a force. Force may be along the work done by a force. If it is not visible, it is a green one, by a force. Work done by a force. It is the first physical interpretation of this line integral. So we take it in this way. We write let F represents a force applied to a particle during its motion, say along arc AB. I will take here. If F represents a force, applied to a particle during its motion along arc AB. It is applied when the article moves. In moving, we will write applied to a force in moving a particle applied to a particle in moving along a arc AB. The work done by force in moving along a small displacement say it is delta R, is given by F dot delta R. This, in my lecture number 9, I have discussed this there. It is actually the small displacement when we took the arc AB. The endpoints of the arc were Pi minus 1 and Pi. In between that we take a point Qi, as you remember in lecture number 9. Then we take a small displacement delta R. What this delta R actually represents? Delta R represents Ri minus 1, where Ri and Ri minus 1 are the position vectors of Pi and Pi minus 1. This is a small displacement. Well, the force, work done by this force in moving a small displacement delta R is given by this. So thus we say, thus the total displacement, apply lecture 9 concept. So the total displacement, so the total work, so the total work done by force F in moving the particle from A to B is given by integral of A to B. Curve is A to B. It is F dot dr, or you may write integral of F dot dr. Whatever R is given, it is A to B. So this is the physical interpretation of the first physical interpretation of the line integral. Then this delta R means the small displacement of the force in moving a particle along a small displacement delta R. It is given by F dot delta R. So when we find out the total work done by this force in moving the particle from A to B, it will be given by, why I use this? It is because the limit of the sum that we did in lecture number 9. That is why I told you just to go through the differentiation, just go through the definition and see there why we use total work done by the force by this. It is the limit of the sum. When this limit of the sum exists, then limit of the sum is a number. If it exists, it is a number, finite number. We denote it by this. This is the work done by the force from A to B. This is the first physical interpretation of this line integral. Do you follow me? Okay, let me have now some applications. I will share with you some applications on this, how we find out the work done by the force. Then next we will go to this interpretation of this line integral, that will be your this circulation. Okay. Application I am writing here. It is find the work done in moving a particle in the force field. Find the work done in moving a particle in the force field. Force field F is given by this. This is your F1, this is your F2, this is your F3 that I discussed in the working rule. I will do the same problem into methods, not two methods, in two ways. There are force field is same, but the curve along which work done is, those are different. Force field is same. This is the curve straight line. First we have to find out the work done along the straight line from 0, 0, 0 to 2, 1, 3 along the straight line. Then the same force field, we change the curve. Sometimes the curve can be in this way. The curve is x square plus 4y, 3x cube is equal to 8z. What is this? They intersect, they form some curve, closed curve. whatever curve they form, we have to find out the work done along the curve. There is a one curve defined by these two curves. Okay, sometimes you have, what is this defined by two curves? Sometimes you have parabola this way, you have parabola this way, you have the parabolas this way, you have parabola, this is the parabola this way, then you have another parabola this way, you may go this way, then you find out the force is applied in this way, you find out the work done by the force along this intersection. So there are sometimes two curves. It is, I will have these problems in the again later on. So this way it is the equation of the curve, it is given in this way, it is a simple straight line, the force field is same, we have this application. Let us have the solution of this one, this application. Let us have a solution. We have given forces F is equal to, it is 3x square I plus 2xz minus y j plus zk. Okay, and your this, what is the work done by this force? We will apply the formula. The work done by the force along curve C. Now curve C will change. In first part this is the curve, in second part the same force, this is the curve. It is given by integral of C f dot dr, that is integral over the curve C. It is 3x square I plus 2xz minus y j plus, it is zk here, sorry, it is 2x minus y plus zk is here, it is zk. Then it is, you know, it is I dx plus j dot j dy plus k dz. What is this? This is your curve C. This is 3x square dx plus 2xz minus y dy plus z dz. Name this for the time being alpha. Okay, now you see what is our curve. We find out the parametric equation of the curve. This thing I will require this alpha work done by the force in both cases, first part and second part. Let us write, it is solution through part 1. This will be here part first solution. What is this? Our curve is this, very simple one. It is your point 0, 0, 0. Suppose I take this point is A, it is 2, 1, 3. It is 2, 1, 3. So what is equation of straight line? I will find out. You know how we find out? X minus x1 by x2 minus x1, y minus y1 by y2 minus y1. It is z minus z1 by z2 minus z1. Equation of the straight line joining two points in space. This is x minus 0 by 2 minus 0 is equal to y minus 0 by 1 minus 0, z minus 0 by, this is 3 minus 0. This gives x by 2 is equal to y by 1 is equal to z by 3. Let us take this equal to t, say. Let us take this t. Do you follow me? I am taking this t. This gives me x is equal to 2t when I take this with this, y is equal to t, take the third ratio with the last, z is equal to 3t. What is this now? Dx is equal to 2 dt. Okay, and what is this? Dy is equal to dt. What is this? And dz will be 3 dt. So I have found out these values. Dx is this, dy is this. Well, for the point, this is very important to find out the range, as I have discussed it in the working rule. You see, for the point 0, 0, 0 to 2, 1, 3, it corresponds to, we have to see here where we get it. We should have x is equal to 0, 0, 0. It is for t0. When you give t0, x0, y0, z0, then it is 2, 1, 3. That means t1. Yes, corresponds to t is equal to 0 and t is equal to 1. I will again explain you here. Your x is 2t, y is t, z is equal to 3t. When you put t is equal to 0, this gives x0, y0, z0. So this is this point. And when you get t1, x is 2t. When you give t1, it is x2, y1, z3. So from the for the point this and this, it corresponds to t0 and t1. Therefore, what is work done by the force? We will use it now, alpha, from alpha. Just a minute, I will use light here. Light is not well. From alpha, work done by force F in moving particle along straight line is given by integral C F dot dr or small dr, but we have found it. What is this now? We have to use it here. It is t going from 0 to 1. T is from 0 to 1. Look here, I am using alpha, from alpha. This is 3x square. What I have to give to x square? X now. X is 2t. This is your 3 x square. X square means it is 4 t square. I am giving value to this x, which is 2t. It is 4 t square. What is your dx now? Dx is 2 dt. It is 2 dt. Then plus, come to this point. It is 2. What is my x there? X is 2t in the parametric substitution. What is z? My z is 3t. It is 3t. Do you follow me? Minus, what is y? What is y? Y is t. Y is t. Here I am giving y. And what is the dy in terms of parameter t? Dy is simply dt. It is dt. Then plus, come to this z dz. What is my z? Your z is actually 3t. Your z is 3t. And what is your dz? It is 3 dt. It is 3 dt. So I have used the, actually what this parameter has benefited me, the integral has converted into single variable t by using the parameter, and dx, dy, dz we have replaced by dt's, different values from here. You look here, it is the equation of the straight line. Now I am in a position to evaluate this. This will be the work done by the force along the straight line. I don't need now these. This also I don't need now. I will simply evaluate this integral now. What is this integral? You see, this is the work done by the force is now integral t from 0 to 1. This is 4 3s are 12, 24. It is 24 t square, then t square dt, then plus this is 4, it is 12 t square, it is 12 t square minus t dt. This is your 9t dt. Well, you can write it now in this way. Integral t is 0 to 1. It is 24 t square dt. This is plus 12 integral 0 to 1 t square dt. It is minus integral 0 to 1 t dt. It is plus 9 integral 0 to 1. It is t dt. You can evaluate in this way also. This is your work done by the force along the straight line we are finding. 24, it is t cube by 3, 0 to 1 limit, then plus 12. Integrate this, it is t cube by 3, also 0 to 1 limit, then minus t square, the integral of t square, again from 0 to 1, then plus 9. Integral of again t dt, it is t square, sorry, it is t square by 2 here, it is also t square by 2 from 0 to 1. This we have simplified this way. Let us see what this gives you. It is actually 8, 1 minus 0, it is 4, 1 minus 0, it is minus 1 by 2, this is also 1 minus 0, this is 9 by 2, 1 minus 0. Let us simplify it. It is 8 plus 4 minus 1 by 2 plus 9 by 2. This gives you 12. Then it is plus 8 by 2. This is 12 plus, this is 16. So this is the work done by the force, 16 units you may say. So work done by this force is 16. This is the question that we have evaluated along the, when the particle moves along the straight line by this force, what is the work done by this force along this straight line. Now the same force, but the curve is changed. Force is same, the force moves the particle along this curve. It is part second. We will do now part second. Now this is the same force. We have solution of part second. This is part second, but force is same. Well, given equations of curve, because intersection of these two curves give the one curve. It is x square is equal to 4y and 3x cube is equal to 8z. Now how you do it? There is a parametric variable that connects the two curves, x here, x here. So better is to put, let us put x is equal to t. We use xt. When we use xt, what we get here? It is t square is equal to 4y and this is 3t cube is equal to 8z. This means this will give me y is equal to t square by 4 parameter. This will give me z is equal to 3 by 8 t cube. Okay, so this means curve C is given by, so curve C is given by, it is given by x is equal to t, y is equal to t square by 4, z is equal to 3 by 8 t cube. This is, here I will need dx, it is dt, it is dt. I will need dy, what is this? It is 2t by 4 dt, that means my dy is t by 2 dt. Here my dz will be 9 by 8 t square dt, because when I differentiate 3 3s are 9 by 8 t square dt. This is my dz. Remember this. Dx, dy and dz I have found from this curve when I use the parameter x is equal to t, because it is a common in both the curves. Well, I will find now the limit here. I will find out the limit. My x is t. Now here the from x is equal to t given, from x is equal to 0 to x is equal to 2, means simply when I give x 0, x 2, where is my x? It is this, x is equal to t, my x is t. When I give x 0, t is 0. When I give x 2, so this implies t varies, t also varies from what? From t varies from t is equal to 0 to t is equal to 2. The range is here. I have to integrate when the curve intersects. There are some points x0 and x2. I have to find out the work done by the force in moving the particle from x is equal to 0 to x is equal to 2. There may be some other intersections of the curve, but he wants me to find out the work done by the force from the curve where x is equal to 0 to x is equal to 2. So I have to use x is equal to 0, x is equal to 2 in this, where I have x is equal to t. This gives me t0, t2. So my range for t will be 0 to 2 again. So what is then work done by the force along this curve C? Thus, in this part, thus work done by force along curve given by part B, given by part second. It is for your simplification I am writing. It is integral of line integral over the curve C. It is simply, I will write f dot dr, or you can write capital whatever you write. I need this x, I need this, I need. I will just rub here, then I will rub the whole thing. This will be by what is this? This is integral t running from 0 to 2, as you did here, t from 0 to 2. Or if I don't use t yet, I can use the curve C here. After this setup I can use t. What is this f dot? You have seen this is 3 x square dx plus twice xz minus y dy plus z dz. This is the work done by the force, because force is same. I am using this alpha. Now this will be I have to use these values xt, y, t square by 2, dx value, dt value. Now this will be equal to, I will rub here, this is now along to, in our second problem, this will be now t0 to 2, t0 to 2. This is 3. What is your x? X is your t, it is t square. What is your dx? Dx is simply dt. Then plus 2. What is x? It is t. What is z? Z is, it is 2t. What is z? Z is 3 by 8 t cube. 3 by 8 t cube. It is your 2xz minus y. What is y? Y is here t square by 4. This is y. Y is t square by 4. I am using it. Then dy. What is dy? T by dy is t by 2 dt. It is t by 2 dt. Okay. Then plus, come here. What is z? It is 3 by 8 t cube. 3 by 8 t cube. It is the parametric substitution. Parts of the curve z. Then dz use. What is dz? 9 by 8. 9 by 8 t square dt. So we have used the value of z 3 by 8 t cube. We have used dz 9 by 8. 3 3s are 9 by 8 t square dt. Let us now evaluate this integral. That will be the work done by this force. Well, you can even do it yourself. It is very easy now. This is integral 0 to 2. It is for the limit t. This is your 3t square dt. Then plus integral. I am distributing the integral. It is 3 by 4. 3 by 4 here. t4 dt. Now you have here actually this t by 2 outside. This I will write integral 0 to 2 multiply with this 2 goes, it is 3 by 8. This will be 3 by 8, taking this to right from right, and this 2 gets cancelled. It is t cube t4, it is t5 now. It is t5 dt. Then minus integral 0 to 2. Now multiply with this. It is 1 by 8. 4 2s are 8. It is t4 dt. Not t4, t square t. It is t cube. This is t cube. This is t cube. This is 2t, t cube. This is t4, and this t is t5. It is okay. Then plus here integral 0 to 2. Now simplify here. It is 27 by 64. It is t5 dt. Okay. Let us now evaluate this. This is 3 t cube by 3, 0 to 2. Then plus 3 by 8 t6 by 6, 0 to 2. Then minus 1 by 8 t4 to 4, 0 to 2, plus 27 by 64 t6 by 6, 0 to 2. You can evaluate it now yourself. This is very easy to evaluate. This is 8 minus 0. This is 1 by 16. 2 raised power 6 minus 0. This is minus 1 by 32. 2 raised power 4 minus 0. This is 27 by 6 into 64. 2 raised power 6 minus 0. You simplify this. Now I leave this to you. You simplify, you find the answer, and then verify it. Well, this is how we find out this work done by the force along the curve. Curve is the given curve is the intersection of these two given curves. This is the parabola and this is some other curve, and it is given find the work done from x is equal to 0 to x is equal to 2, and we have used the parameter there and put the value of x in that parameter. We have found out t. Then we used this working rule. This is the work done by the force. Whatever the result is, it may be in units. Thank you very much. This is the first interpretation or application of this line integral. Next we will come with another lecture. There we will again apply the line integral in fluid dynamics, how we find out the circulation by in fluid in circulation of the fluid in this fluid dynamics. Then we will again use the line integral there. Thank you very much. See you next. Wish you all the best.